Group 7, the halogens. The elements in Group 7 of the periodic table are over on the right. They're called the halogens. Starting at the top, we have fluorine, chlorine, bromine, iodine, and astatine. What do they look like? Chlorine is a green tinted gas. Bromine is a reddy brown liquid, and iodine is a purpley silvery solid. The halogens form vapours, so bromine and iodine are not gases, so bromine is a liquid and iodine is a solid, but their boiling points are very low. This means that they produce vapour or gas at relatively low temperature. In other words, they are volatile. Bromine, which we've just seen was a reddy brown liquid, that also produces a reddy brown gas. And here you can see it in the gas jar just above the liquid layer. Iodine is a solid, and when you heat it, it doesn't ever become a liquid, it becomes a gas straight away. The gas it forms is a purpley gas, and becoming a gas without becoming a liquid, so solid going to gas, is called sublimation. We can use the periodic table to predict patterns. So if we know that chlorine is a gas, bromine is a liquid, and iodine is a solid, can you use the periodic table to predict the state of fluorine and predict the state of astatine? The electronic structure of group 7 is shown here for two of the elements. So fluorine, it has the atomic number of 9, so it has 9 protons. That means it also has 9 electrons. The electrons are arranged in the energy shells, with 2 in the first energy shell, and that leaves 7 for the second energy shell. Chlorine has the atomic number of 17 protons and 17 electrons. Here are the electrons: 2 in the first energy level, 8 in the second energy level, and that just leaves 7 for the outer energy level. So both fluorine and chlorine have 7 electrons in their outer energy levels. Can you use the periodic table to predict the number of electrons in the outer energy shells, outer energy levels of bromine and iodine? How do halogen molecules exist? Well, they all exist as diatomic molecules. So fluorine exists as F2, chlorine as Cl2, bromine as Br2, and iodine as I2. This is because, in order to become as stable as possible, the halogens require one more electron in their outer energy shell. And they can gain this extra electron if they share it with another atom of the same element. So in this picture, we have 2 fluorine atoms. They both have 7 electrons in their outer energy shell. So the first fluorine molecule has 7 light blue circles in its outer energy shell, and the second fluorine atom has 7 light blue crosses in its outer energy shell. And they would really be much more stable energetically if they had 8. So by overlapping their outer energy shells, they can share an electron, and now they both have 8. 7 circles and a star for the first fluorine atom, and 7 stars and a circle for the second. We can use the periodic table to predict a pattern. Can you predict the formula for astatine?